How to manage Docker containers at scale. While Docker containers make it extremely easy for you to package your applications and realize greater efficiencies in your overall coding life cycles, our next speaker is Jason Omiker from AWS, who's going to be talking about how to do this at scale, possibly in a cross region, across multiple machines, and across massively huge setups. And what are the learnings from some of the customers that we've seen on the field, which go directly into how well you can operate containers at scale. Thank you.
He said, my name's Jason. I'm a solutions architect with Amazon in Sydney. And if you came to hear about running containers at scale on AWS, then you came to the right place. So there's a number of reasons why our customers are using containers. The first and foremost is speed. They launch faster, which means that you can scale faster, deploy faster, and your applications can heal faster, which is a key advantage. They're more efficient, so you can make more complete use of your underlying compute instances and thereby save some money. They have easier packaging, so with many of the runtimes these days, like Node and Python, packaging everything together in a way that's consistent and that you know it's going to run is a bit of a challenge, and containers really help here. Also, because it makes it easier to package applications for developers, it gives them a better experience. They know that running the application on their laptop will be consistent with production. And finally, because the containers run on the laptop the same way as in production, your deployments are less risky. The main driver, though, really is microservices. So what used to be one service that you were running has in many cases become 20, 30, 40 services as it's decomposed from the big monolith down to these microservices. And this doesn't just mean that we're running 30 times the number of services, but it means that each of these services needs a pipeline to deploy it, and this increased scale of the number of services being run has justified a new approach to how we do things. And that's containers. The other big constraint here is that when it was one big service or monolith, the functions that were being called within the monolith were all happening on the same machine in the same memory, and so they didn't really have a latency constraint. Whereas as we decompose them, this requirement that they all communicate with one another, you need to keep this in mind, and this is something that's been a bit of a challenge. And as we said earlier, the packaging, particularly for some of the more modern languages like Node and Python, has been a challenge. So while containers have helped address many of these things, they have their own challenges that are new to containers. They're very transient, more transient than things have been in the past. They can come and go within seconds, and so keeping track of what's happening and monitoring it is more complex. The container clusters that run these things are more complex distributed systems in their own right that customers have been trying to run, so that's been a challenge. And finally, the security of containers is enforced at the kernel level. That's where the isolation between things happens, and so keeping your kernels secure and patched has been a bit of a challenge as well. What this talk is about is how Amazon can help you with these challenges. They all have solutions, and we're going to talk through some of them. Because this is a container talk at an AWS Summit, I think it's important to give you the general strategy of Amazon when it comes to containers. And that strategy is one of choice. We give you the power to choose, not just between our traditional scheduler, the Elastic Container Service, but also Kubernetes. And then for each of these, we're giving you a choice between two modes for running them. One where you bring the EC2 instances and you have a lot more control over what instances are used and their scaling and also their operating system. And then the new Fargate mode where we take care of all of these things for you. Today we're going to be talking about ECS because ECS is generally available in all of our regions, including Mumbai, whereas EKS is in preview at the moment and is not yet generally available. And Fargate for ECS is generally available in 4 of our regions, Virginia, Oregon, Ohio, and Ireland, and hopefully Mumbai soon, whereas Fargate for EKS is not yet available in its preview. So the agenda for today's talk is we're going to have a brief introduction to ECS. We're going to talk about some best practices that we've seen in our customers on how to go big with containers on ECS and in Amazon. We're going to hear a few customer case studies for how this has been done well by our customers. And finally, we're going to hear from a local here in Mumbai, CleverTap, on their experiences with containers. And Francis will come up and join us in a minute. So Amazon's Elastic Container Service. This is a managed service for managing your containers. It's well integrated with the platform, highly scalable, highly available, and it's a great way to run your containers at scale with minimum operational effort. How it works at a high level is that you bring instances that have Docker installed as well as our ECS agent installed. That ECS agent checks in with a control plane that we run for you. And that control plane tells the agent to tell Docker to run tasks. And these tasks can be one or more containers that are run together on an instance and have the same network and security boundaries. Optionally, they also integrate with a load balancer to expose these services either within your own environment or out to the internet. There's a lot of reasons why ECS is great. It's well integrated with the platform. It's got a great CLI and API to make running your containers easy and automatable. And two of these features in particular are recent additions. We launched at reInvent last year a new networking mode where you can have a dedicated network interface per task, and also a new service discovery mode whereby you can more quickly update Route 53 to expose your services in a way to quickly integrate with other microservices and these common microservices patterns that we're seeing throughout the industry. Whenever we talk about a service in Amazon, when you want to know about its operational and security characteristics, we always look at it through the lens of this shared responsibility model. So in the case of traditional ECS, this is what that looks like. So Amazon's responsible for the ECS control plane, whereas the customer is responsible for bringing the instances, thereby picking the right instance type, how many of the instances they want to run, across how many availability zones they want to run them. Also the operating system. So you could use Amazon Linux, you could use Red Hat Enterprise Linux, and also the patching of that operating system. All of these things are on the customer's side of the line here, their responsibility. So Fargate moves two of these things down to being our responsibility. So you don't need to worry about any of the scaling anymore or instance type selection, any of those things. Additionally, we take care of the whole operating system for you. So you just have to worry about your containers, what's in their images, as well as the configuration that you give ECS, the task and service definitions. So this is just a few of the logos of customers that are using ECS happily at scale. Missing from this is the customer you're going to hear from in a moment, CleverTap, but we have also many customers in India that are using it successfully too. And so now we're going to talk about some general best practices and patterns that we've seen customers be successful with when it comes to running their containers at scale. The first and probably most important point is security. So security is critical and everybody's responsibility, both the customers and Amazon's. And some best practices to maintain the security of your containers are to leverage IAM roles, which basically delegates to Amazon all of the things involved with getting temporary access keys and secrets to our APIs and rotating them. So we take care of all of that for you and help you to use services like DynamoDB and S3 from the code in your containers in a very easy and secure way from a credential perspective. For those credentials that aren't our API, there's a number of secrets managers. We offer two, the Parameter Store, which has been around for quite some time now, and our new Secrets Manager, which just launched recently. And there's third-party solutions that can be used here. Popular one is HashiCorp's Vault. So using these secrets managers to make sure that your secrets are secure and can be rotated is very important. Whether you choose our CloudFormation or HashiCorp's Terraform, making those changes via pipelines rather than having developers independently deploying the changes from their laptop is critical. In the case of Terraform in particular, if they have enough rights to invoke the Terraform, then they have enough rights to change everything in your environment. And so limiting that role to a pipeline which can be more properly managed and change controlled is key. And finally, IAM lets you have really secure policies, but it also can let you have very insecure policies. You can go and put asterisks or stars for all of the resources, and you can quickly make things rather non-granular and insecure. So err on the side of least privilege wherever you can, and be very specific in your IAM policies to make sure that things are secure. One way to do that is to have automation so that everything gets created a role as it's being progress through a pipeline. And that kind of leads into our next point, which is when you're going big, when you're truly doing things at scale, everything needs to be automated. And that's an investment that pays dividends. So whether it's the building of your code and containers, your infrastructure, which is ideally done in an infrastructure as code pattern, your deployments, your healing, or your security, automation is what allows you to really move fast and to do it in a way that's reproducible and secure. And the most important point is that you should be striving to have your automation make it fast and easy for your staff to do the right thing. We'll come back to that point in a minute. Another key to operating at scale is to delegate whatever you can to AWS with our higher level services. When it comes to running databases and caches and streams, these are difficult services to run well, and it's not really a differentiator for your business unless you're a cloud company like us to do it well. So delegate that responsibility to Amazon so you can focus on the code that's really adding value to your customers and delivering on your business outcomes. When it comes to containers, smaller is better. Not only is less is more secure, but it's also more performant. The smaller an image is, the faster it pulls, so the faster things deploy and heal. And so limiting the blast radius and putting as little in there is the goal. As we said, putting secrets in there is a bad pattern. That's what secrets managers and IAM roles are for. Use trusted base images like the official images on the Docker Hub, or even better yet, get the Docker file that corresponds to that image and build it yourself so you know exactly what's in it because you're responsible for it in this model. And finally, use unique and informative image tags. So if instead of saying like latest for your tag, you have a git commit ID, you can search for that git commit ID in your repo and work out exactly what's changed and who changed it and why they changed it at a glance, which is very important. There we go. One of the key benefits of microservices is decoupling. And this picture, I think, is truly apt because when you have a train and all of the cars are coupled, they either are all moving or none of them are moving. And this is often what happens within our organizations. The person who literally wrote the book on this, Sam Newman, who wrote Building Microservices, put it, can you make a change to one thing and deploy it without changing anything else? And that's the goal technically, but I would go one step further and say organizationally, can one team make a change without having to tell anybody else? And if you can hit this, then you can have faster and easier changes and much more agility in your business. You could choose the right tool for the job, scale things independently, and let each team focus on doing one thing and doing it well. The other big advantage of decoupling is to isolate your failures. So this image is actually a World War II era battleship being constructed. And as you can see here, they're building watertight bulkheads to make it so that if one part of the ship is flooding, the ship doesn't sink, and ideally the ship operates in a bit of a degraded state maybe, and can get back to port and fulfill its mission, right? So in the case of microservices, this is exactly what we're doing, but instead of watertight bulkheads, we're introducing either queues between services, so an asynchronous pattern, or we have APIs which on the one hand throttle their subscribers, and on the other retry with exponential backoff. So if you follow these patterns, then one part of your wider application can flood while the rest of the application can continue to operate, perhaps in a degraded state, doesn't sync. So there's a few different patterns that are popular to do this. The key here is that you have different services, each of which have an API, and that they own their own data stores. So if you have a situation where two services need to share a bit of data, it's tempting to just have those two services talk to the same database. However, when you do that, you've coupled those services in a way that's difficult to remediate, and it kind of leads to that coupling and grinding things to a halt over time. So the thing to get out of this slide is that wherever possible, only have one service own each data store, and then have it expose that via an API to the rest. Another really great pattern is to do things asynchronously. And I like to think of this queue here as a shock absorber or spring. So when you decouple things through an asynchronous pattern, you give yourself the flexibility and time to scale out of problems. And it's a much more powerful mechanism for allowing true decoupling and scale. So we have a bunch of material on how to do microservices well and how to do them well on ECS. One of our developer advocates, Nathan Peck, has a lot of great material here. So these slides will be made available to you afterward, but if you want to take just a picture of some of these URLs, these are some great content elaborating on this some more. So let's talk about some customer case studies. GoPro probably needs no introduction. They make not only great cameras, but now they make great cloud services to go with their cameras that let you store, access, edit, and share videos that you're taking with your GoPro camera. They truly are going big. They have more than 40 services running on ECS in production, and those take up to 500,000 API requests per minute at peak. So they are at a pretty decent scale. And they were also able to be fast with ECS because moving this process to a container and running it on ECS took them less than a quarter to complete, and it let them reduce their EC2 footprint by 70%. So I'm going to let them talk a little bit about how they've done this. So this is a short video that we're going to play, and I'll let GoPro explain how they've done it.
And how does that come in as far as the system we see up here? If I want to go in and start editing a video, where does it happen?
So it actually happens with a combination of our backend services that are in ECS and SQS. So all of the jobs are put into SQS, and they're picked up by containers that are running in EC2 over here. So we have containers that are pulling SQS queues, and then they're picking up jobs in a JSON-based format, and then returning the results to the user or to a different worker.
Okay, so all your customer requests for everything is, first point of landing is SQS, and then the ECS cluster itself is actually picking up off that queue and divvying up all the duties.
Exactly.
Cool. How do you handle the management of your ECS cluster? What do you do for scaling upon customer load or anything like that?
Yeah, so we have all of our clusters in an auto-scaling group,
Yep.
so they can scale horizontally with instances. So in the case where we need to expand more compute, we can do that on the fly. We also have auto-scaling at the ECS level with our tasks. So
the services themselves.
exactly.
Right.
So we have tasks running in here in containers, and they actually scale up or down based on the size of the queue. So more messages in the queue, more work, more containers respond.
Cool. So let's talk about what they just said and why it's great. So they didn't need to build and operate a container orchestrator or a queuing service, which were two pivotal parts of that when it came to scaling. They also used services like S3 and Elastic Transcoder, which were key elements of that whole process that, once again, we were responsible for the scaling of and they weren't. So that's always a win. And they built it with an asynchronous pattern where a customer uploads a video, asks for a particular thing to be done, and then they're told when it's finished. And so that lets them have this asynchronous pattern that decouples the application on people's phones and the API from this batch processing where the work is done. And that queue gives them a shock absorber and the time to scale, which is a pivotal thing. They speak in another video that I'm going to link you to about some lessons that they've learned in this process. And one of those lessons was that they left a buffer of 20% extra capacity on their ECS cluster to let them start scaling while the instances were coming up. Because containers launch very quickly, but the instances take a little bit longer. So having that buffer allowed them to make sure that they were never out of capacity. They talk about with Terraform how they needed to put that into a pipeline rather than having developers deploy it, like we had said earlier. And finally, they were able to decouple bits of their Terraform from each other. So instead of so the bits of it that didn't change very often were segregated from the bits that changed all the time, and it made the blast radius of any one change a bit more manageable. So here's a link to the video that you just saw. That was a short clip of a longer video. And then there's another video where they speak in depth on their approach at our container loft in San Francisco. So definitely go and watch those. This other customer, Expedia, doesn't need any introduction, I would hope. If you've booked travel, you probably did it with them. What you may not have known, though, is that at the last reInvent, they announced that they're going all in on Amazon, which is we're thrilled to have them as a customer. And we're going to talk a little bit about what they've built on top of ECS. It's an entire platform for running microservices called Primer, and these numbers are truly big. We're talking about over 1,000 applications, over 2,500 ECS services, 13,000 containers running across 860 instances. They've deployed across 5 of our regions, and they're doing well over 500 deploys a day to their test environment. So truly great numbers and scale. I'm going to let Expedia talk a little bit about what they built and how it's gone for them, though. So here's another video.
So internally within Expedia, we've created a microservice generation platform. We call it Primer. And teams will go to the internal Primer tool, into the UI, and they'll click a button, I want to create an app. And they can choose from a number of different templates, some JVM, Drop Wizard, Spring Boot templates, some Ruby-based templates, Python, PHP, Scala, whatever's been created by the internal community will be available to the developer. We'll go through a series of processes to create the application, the Docker image, and the builds. And within 10 minutes, they'll have an application repository for their microservice with a continuous delivery pipeline ready for commits, a Docker repository. The application will be built as a Docker image and deployed to a prod-like testing environment. So within 10 minutes, they can get started with their experiment. All those things that could possibly take you 2 weeks or a month to do within an enterprise. Our teams within Expedia do this 20 times a day. Every business day, there's 20 new microservices created. Just because the cost is so low that people can easily make an experiment and say, I want to test out this particular idea that I have. You might be wondering what those distracting spikes are. Hackathons. People getting excited about hacking away on some new ideas. So going back to the question, how long does it take to create a microservice? If it takes more than a few days to go through this process, all the approvals and everything, then your teams are unlikely to consider even doing this. The time burden's too great, and there's
the benefits of what they've done is they're making it fast and easy to do the right thing. And what we see in this image is the classic kind of example of human behavior. If you put barriers in front of people, if you make something difficult, they're just going to go around whatever you're doing, and they're going to do it in a way that is probably not what you want, right? So what the right thing meant at Expedia was that they wanted people to develop and experiment in microservices rather than changing the code in their legacy monoliths. They wanted more control over their changes and deployments, and they wanted consistently deployed and operable services. So they've built the automation to make it easy for their developers to do this. So one of the most critical times is when you're changing things, and so I'll let them talk a little bit about their deployment process, which is environment when it's changing.
And when it comes to deploying to ECS, we split down the deployment phase and the release phase. And what that means is that we want to allow a way for teams to test their container is working in the target environment before they send live production traffic to it. What that looks like is this. So they have a service already running, their application's running on version 1 in ECS. The 4 boxes there represent 4 tasks, each running its own copy of the container that they've built. That service will be behind a load balancer, which is behind a Route 53 CNAME. We want to go to version 2. So what we'll do is create a separate ECS service called the Canary service, and we'll deploy a single task just for testing. That's going to be on version 2. It's the exact same application, but a newer version of the image. That's behind its own load balancer and its own Route 53 CNAME. And teams can begin testing against that Canary. When it comes to, we call that the deploy. And then when it comes to release time after they've tested their deploy, we use the Amazon's ECS update service command, which says, okay, take this live running service and do an implicit blue-green deploy on there. And what that does is basically treats it like an implicit blue-green deploy by saying, I'm going to create all replacement tasks, the green tasks there, and then you've kind of in mixed mode there. You've got both version 1 and version 2 running behind the load balancer. And then once version 2 tasks are successfully placed behind the load balancer, it removes the old blue tasks, and then you're running your live service purely on version 2. And then we go ahead and delete the canary. So that's how we do.
And finally, they talk a little bit about the benefits they've gotten from having invested all this in the automation and what they're doing. And so I'll let one brief more clip, and we'll hear about some of the benefits they've gotten from this whole thing.
So reduced cost of experimentation and that fast feedback. The deployment automation gives us that speed and safety when it comes to reducing a lot of manual steps down to repeatable, reliable steps at the click of a button or fully automated. And then the cluster management, the investment we have there in keeping those ECS clusters maintained, it means that we've got those pre-built instances there ready to receive Docker workloads and giving the ultimate speed at deployment and auto-scaling time. And also the sharing of those Docker layers that I mentioned increases the speed, the immutable server approach, no configuration drift, and the ability to auto-scale horizontally. So that's just to summarize the benefits we get. So did we succeed? I mentioned that our mission as a cloud acceleration team is to speed up developers' lives, to make their lives faster and easier. So our hypothesis was, going back 2.5 years now when we embarked on this journey, we thought that we could make developers' lives faster, maybe double the speed at which it takes to deploy using Docker instead of dedicated EC2 instances. So our initial primer approach did use Docker EC2 instances, and that would use Chef to build AMIs, and it would take about 30 minutes to deploy because it needs to spin up a new instance, it needs to pull down Chef, set up all the configuration and software, and it needs to burn an AMI and then create a CloudFormation stack. For our 2.0 approach using Docker with ECS, it takes 3 minutes to do that process. And this is just talking about the initial deploy to the initial testing environment, so to get production-like feedback. So we receive that feedback as a developer. Every commit, you'll receive that feedback 27 minutes faster because it takes advantage of having that shared ECS infrastructure. And our developers do, on average, 524 deploys per day, per business day, to our initial testing environment. So if you multiply that out as you go further right, you'll see that 524 times 27 minutes, that's a saving of about 29.5 business days every day. So that means that our developers will receive that feedback. And this is the most critical feedback, right? It's the, will this commit that I've made, will this change I've made actually work in a production-like environment?
Some of the lessons that they learned were around knowing and working around your limits. So Amazon has some soft limits which you can ask to be increased, and some harder limits which are constraints you need to work around. And so they speak a bit about this in the video. I would recommend kind of watching it for more detail. And they also recommend being very careful with your auto scaling. They give an example where if you scale on both CPU and memory, they saw this thing where they would scale up due to there not being enough memory, and then it would scale back down again immediately because they weren't using very much CPU. So being careful with these is very important. So once again, here's some links to that talk that you saw, as well as some other things from Expedia. If you wanted to watch those, I highly recommend these videos. They're great.